Hello, good morning students. I am Dr. Sunita Tandon from RR College, Alwar. Today I am going to start the new unit of your syllabus of MSc final semester 3rd, that is Environmental Chemistry Unit 4, and it is water pollution. Today I am going to start with lecture number 1. First of all, we will learn the introduction. Hydrosphere consists all type of water resources, namely oceans, seas, rivers, streams, reservoirs and glaciers, etc. Water is a vital natural resource which is essential for multiplicity of purposes, namely drinking, agriculture, power generation, transportation and waste disposal. In the chemical processes, industrial water is used as a reaction medium, a solvent, a scrubbing medium, and a heat transfer agent. As a source of life for man, plants, and animals, it cannot be replaced by any other solvent. Now we'll study about water resources. The chief source of water are rainwater, seawater, ground and surface water. The world total quantum of water is 140 into 10 to the power of 16 meter cube. Sea water, about 97% of Earth's water supply is in the ocean, which is unfit for human consumption and other uses due to high salt content. Of the remaining 3%, 2.3% is logged in the polar ice caps. They are logged in the polar ice caps and hence out of bound. The balance of 0.7% is available as fresh water. If all the sea beds could be filled up and brought at the level of the earth's surface, then the entire water in the seas would cover earth's surface and make 2.5 kilometer deep water mass. Now groundwater. Groundwater, a gift of nature, is about 210 into 10 to the power of 9 meter cube. Metric tons or meter cube, and it is 0.66% including recharge through infiltration, seepage and evapotranspiration. Out of this, nearly 1/3 is extracted for irrigation, industrial and domestic use, while most of water is regenerated into rivers. Of the fresh water below the surface, about 90% satisfies the description of groundwater, that is, water which occurs below the water table. About 2% water occurs as soil moisture in the unsaturated zone above the water table and is essential for plant growth. Surface water. The major portion of water, about 165 into 10 to the power of 10 meter cube, which goes to each earth crust, is retained as soil moisture. Only 500 into 10 to the power of 9 meter cube percolate down to the ground water deposits. About 120 into 10 to the power of 9 meter cube of water applied to agriculture fields moves down to ground table, and 50 into 10 to the power of 9 meter cube of surface flow also end up as groundwater. Thus, a total of 670 into 10 to the power of 9 meter cube water, fresh water, enters the ground annually. Now we will learn about surface water. We have a very limited stock of unusable water, that is 0.03% of the mass balance. The 115 10 to the power of 10 meter cube of surface water is enlarged by the addition of 450 into 10 to the power of 9 meter cube of fresh water from groundwater flows, 200 into 10 to the power of 9 meter cube from surface flows, and 50 into 10 to the power of 9 meter cube as runoff from irrigated areas. The surface loses almost 50 into 10 to the power of 9 meter cube of its water, which percolates down to the groundwater deposits. The total surface flow per year is 185 into 10 to the power of 10 meter cube, which are distributing among river basins. Then comes the rainwater. In India, the annual rainfall is about 400 into 10 to the power of 10 meters square. Out of this, 70 into 10 to the power of 10 meters square of water evaporates immediately. 115 to 10 to the power of 10 meters square run off into surface water bodies and remaining percolates into the soil. The hydrological cycle in nature is more or less balanced in terms of charge, cloud formation, and discharge rainfall. Out of the 30% stream flows water, 12% for electrical utilities, 4% for transportation and waste disposal. By 2010, the total water requirement is expected to thrice as much as we had in 1974. The wastewater from these is extremely polluted and on mixing with rivers is polluting the river also. With a rapid growth of pollution, many countries in the world are now thinking of desalinate seawater as a potential source of supply of potable water in scarcity hit regions. Desalination may be accomplished by processes such as distillation, freezing, electrodialysis, and reverse osmosis. WHO or World Health Organization has estimated that water consumption will have to be cut by 50% by 2025 if nations fails to address imbalance in global water supply and demand. Some European companies have ventured into water business by supplying water to water thirsty countries across the oceans. Nordic Water Supply, that is Norwegian company, had been transporting fresh water in giant floating bags across the ocean. In future, the company plans to build new bags of size of super tanker. Thus, the Nordic company is engaged in business of tolling fresh water from Turkey to Greek islands. Now we will study the hydrological cycles, though we have studied it earlier in the first unit where we have studied various biological cycles. The hydrological or water cycle. The hydrological or water cycle is the most important of all natural cycles in the biosphere. The cycle involves a continuous natural process which helps in exchanging of water between the atmosphere, the land, the sea, plants, and animals. About 1/3 of the solar flux absorbed by the earth is used to drive the hydrological cycle. That is, solar radiation require 8.2 into 10 to the power of 20 kilojoules kilo per joules for massive evaporation of water, which is nearly 15% of the total radiation reaching the outer atmosphere. Hydrological cycles may be having either a long or numerous short cycles. Now we will study the various stages of hydrological cycle. First है evaporation, condensation and precipitation. The hydrological cycle depends on the reciprocity of evaporation and precipitation. Water on the earth goes into the atmosphere as vapor by evaporation and transportation from the plants, as you can see in the figure 1. More than 80% of the total insolation that is not lost immediately as electromagnetic radiation evaporates the water. The vapors of produced can then condense around dust, that is nucleation particles. Other nuclei may be particles of spores, pollen grains, or fine material particles. Small droplets, 0.0 mm, of condensed liquid remain as cloud in the atmosphere and finally get precipitated as rain, hail, or snow under the influence of gravity. Second is surface runoff. In the event of good rainfall, all the rainwater precipitated on land does not percolate into soil. Surface water or runoff flows into the streams, rivers, lakes, and catchment areas of reservoirs. Third is groundwater movement. Water on land surface seeps into the soil as groundwater. The soil below the natural water table is sustainably by the underlying clay and rock strata. Groundwater does not remain stationary but moves up above the water table and thereby maintain a continuous supply of water to the surface layer of soil. Plants absorb capillary groundwater but give off excess water through leaves by transpiration. This is an important process which ensures conduction of water and dissolved mineral salts throughout the plant. Another underground water resource is the aquifer. It exists as an impermeable rock bed. Water percolates through the porous rocks and forms underground lakes or reservoirs. From these aquifers, water can be extracted by sinking wells, tube well, and pumping equipment. Hence, the hydrological cycle consists of a balanced continuous process of evaporation, transpiration, precipitation, surface runoff, and groundwater movement. Note that normal evaporation from the ocean exceeds precipitation by rain into the seas by about 10%. This exceeds 10% ultimately moves as water vapor through air and surface and thereby balance the hydrological cycle and meet our requirements. An approximated estimate about the quantum of annual rainfall and evaporation may be given each year by 50 pm. 1 pm is equal to 1 tetra cubic meter or is equal to 10 to the power 12. That is 1 million cubic meter. 1 million cubic meter, 1 meter, and 1 meter cubic meter is equal to 1000 liters. Water is evaporated, and the same quantity of water is precipitated over the earth's surface. From the land, about 45.5 pm3 water flows to the sea per year, and this is available for man's water supply. Minor local modification of the hydrological cycle are made by diverting the runoff and storage phase of fresh water for domestic 4%, industrial 4%, thermal 4%, power generation 12%, flood control 1%, irrigation 8%, and recreation. Thus, without water or hydrological cycle, biological cycles could not occur, ecosystem could not function, and life could not be sustained. Thank you, students. Next lecture we will study the chemical composition of water bodies. Thank you.